Welcome to this explainer. Today, we're putting on our medical tutor hats and mastering the lacrimal apparatus from first principles. We're going to take you all the way from normal anatomy straight through to clinical diagnosis. By the end of this, you won't just be memorizing facts. You'll deeply understand the why and how behind them. This is going to set you up perfectly for your clinical rotations and those big board exams. So, let's jump right in. Here's our roadmap for today. The big picture, anatomy of drainage, physiology and the tear film, pathology of dry versus watery eyes, clinical diagnostics, and finally, a high-yield exam review. Let's get started.
Section 1. The big picture. Understanding why we need tears.
All right, so think of the lacrimal apparatus as the ultimate plumbing and irrigation system for the front of your eye. Now, why does it even exist? Well, think about the cornea, that clear window at the very front of your eye. It literally cannot have blood vessels, right? Because if it did, you wouldn't be able to see through it. But since it has zero blood supply, it relies entirely on this continuous, flowing river of tears. These tears deliver atmospheric oxygen, they wash away cellular debris, and they provide crucial immune protection. If this system fails, the cornea starves, it dries out, and your vision is immediately threatened. Section 2. Anatomy of drainage. The anatomical journey of a tear. Let's visualize the story of a single tear. Imagine a drop of water leaving the eye. First, it enters these tiny little holes on the inner corners of your eyelids. We call those the puncta. From there, it flows through the 8-millimeter horizontal tubes, the canaliculi. These tubes usually merge together and empty out into a much larger collection area called the lacrimal sac. And finally, gravity and pressure take over. The fluid drops down the nasolacrimal duct, traveling right through the bone and empties directly into your nose. And hey, this anatomical connection, that is exactly why your nose runs when you cry. It's all connected. Section 3, Physiology and Tear Film. How tears work and move. Now, the tear film isn't just some simple splash of salty water. It's actually a highly structured 3-layer shield. And here's the kicker. If any one of these layers is compromised, the entire system collapses. You've got the lipid layer on the very outside, the aqueous layer right in the middle, and the mucus layer on the inside, sitting flush against the eye itself. Let's break down the first principles here by asking why. The outermost lipid layer is basically an oil slick produced by the meibomian glands in your eyelids. Its one job, to trap the water beneath it so it doesn't just evaporate into thin air. Then you have the thick middle aqueous layer from the lacrimal glands. That's the watery part bringing in the oxygen and immune proteins. Finally, the inner mucus layer from the conjunctival goblet cells. Why on earth do we need mucus? Because the raw surface of the cornea actually repels water. It's hydrophobic. The mucus acts like a biological glue, turning a water-repelling surface into a beautifully wettable one. Okay, so how do these tears actually physically move into that drainage plumbing we talked about? It is all about the mechanics of the blink. The orbicularis oculi muscle acts as a mechanical pump. When you blink, that muscle contracts, creating positive pressure that literally squeezes the tears down the tubes and into your nose. Then, when you open your eyes, the whole system expands. This creates a vacuum, a negative pressure that sucks fresh tears off the surface of the eye and into the sac. It's just a brilliant, continuous, dynamic pumping system.
Section 4. Pathology. Dry versus watery. When the system fails.
So imagine a patient presents to your clinic complaining of a chronically watering eye. You immediately have to compare two potential system failures. Is the eye actively overproducing tears, which we call hypersecretion? Or is the production totally normal, but the drainage plumbing is blocked or broken? The absolutely crucial concept here is epiphora. That's the fancy medical term for the physical overflow of tears running down the cheek. And ironically, one of the most common causes of this overflowing wet eye is actually having a dry eye. Sounds crazy, right? Let's explore exactly how that happens.
We call this the dry eye paradox, and it's a massive cause and effect chain that you absolutely need to understand. Imagine a patient whose outer lipid layer is weak. Because there's no protective oil shield, that middle aqueous layer evaporates. Boom, the cornea gets painfully dry. Now, the fifth cranial nerve senses this severe dryness and panics. It triggers an emergency reflex, dumping a massive amount of watery tears onto the eye to compensate. But remember, there's still no oil layer to hold it in place. So these new tears, they just roll right off the eye and down the cheek, totally overwhelming the eyelid punk. The body tries to compensate, but the compensation fails.
Conversely, what if tear production is perfectly normal, but the patient still has epiphora? Well, that points to defective drainage.
The physical pipes might literally be blocked by a stone or a tumor. Or maybe the eyelid is sagging outwards, pulling the puncta away from the tears, a condition we call ectropion. You could also have a lacrimal pump failure. For instance, if a patient has a facial nerve palsy, their orbicularis oculi muscle is paralyzed. They literally can't blink to pump the fluid away. Finally, you could be looking at dacryocystitis, which is a really painful swollen infection of the lacrimal sac itself.
Section 5. Clinical Diagnostics, Investigating the Watering Eye. Okay, so how do we figure out what's going on clinically? We always start with a primary fluorescein disappearance test. We place a drop of bright yellow-green fluorescein dye right onto the eye. Then, we just wait 5 to 10 minutes. In a perfectly normal system, that blink punk will wash all of the dye straight down into the nose. But if we look at the eye 5 minutes later and it's still completely flooded with yellow dye, we know for a fact that the drainage system is not functioning properly. Now, if that primary test proves there's a backup, our next job is to find the exact location of the blockage. We follow up with the secondary dye test. We take a tiny, blunt cannula, insert it gently into the puncta, and flush the system with saline. Here's the trick. If the patient tastes stained, salty water in the back of their throat, it proves the fluid made it all the way through the upper tubes and into the nose. That means the upper canalicular passages are fully patent, open, and working, so the obstruction must be a partial one, much further down the line. But if the fluid just splashes right back out onto their cheek, we know we've got a hard physical block up top. Section 6. High-yield exam review, quick revision, and must-knows. All right, let's do a little active recall to test what you've internalized so far. Why might a perfectly healthy newborn baby present to the clinic with epiphora in just one eye? And what is the expected clinical outcome? Take a second and think about the anatomy we just walked through. Have your answer? The secret comes down to embryology. The very bottom of the nasal lacrimal duct, specifically mucosal fold known as the valve of Hausner, is the absolute last part of the system to open up or canalize before birth. Sometimes babies are just born before it opens, but impressively, 90% of these cases resolve completely on their own by age 1, often with just a little help from the parents doing a gentle downward massage over the lacrimal sac to pop that membrane open. Okay, here are your 5-star must-know revision points. If you remember nothing else for your exams, memorize these. Know the 3 tear film layers and their exact glandular sources: lipid from meibomian, aqueous from lacrimal, and mucus from goblet cells. Understand that the orbicularis oculi muscle is the absolute engine of the lacrimal pump. When you see a question about epiphora, immediately map it in your brain to either hypersecretion or defective drainage. And lastly, remember that in a primary dye test, dye recovered in the nose equals healthy patent plumbing.
I also want you to beware of an incredibly common exam trap. You might get tested on what the quote-unquote gold standard test is for evaporative dry eye. The trick? There isn't one. Diagnosing evaporative dry eye is presumptive. It requires you to act like a detective, piecing together clinical findings like tear breakup time, corneal staining, and meibomian gland health, rather than relying on one single magic blood test or scan.
I'm going to leave you with this final provocative thought. If the crucial lipid layer is essentially just an oil slick and our natural blinking mechanics physically regulate its release, how might we, one day, bioengineer our eyelid muscles or the neurology driving them to permanently cure evaporative dry eye? Could we actually fix the hardware rather than just constantly adding artificial teardrops? Something to think about. Thank you so much for joining me on this deep dive into the lacrimal apparatus. Keep reviewing those core concepts, and I'll catch you in the next explainer.